Part B is a two-link planar robot. So in this one, we're giving values of L1 and L2. L1 is 11 centimeters, L2 is 7 centimeters, and it wants to determine the values of x and y. And what we just figured out in part A was that x can be found using this equation, L1 times the cosine of theta 1 plus L2 times the cosine of theta 1 plus theta 2. And y equals L1 times sine theta 1 plus L2 times sine of theta 1 plus theta 2. So given those, we can get these different ones. And so we've got a list of questions here. We'll start with I. It tells us that theta 1's at 0 degrees and 2 is at 90 degrees. And so I'm going to draw a quick axis, a quick XY axis here, so we can kind of think these things through. Will help us solve them. And I'm going to bring back our little Lego pieces to kind of think this part through. And so these aren't exactly proportional, but what you'll find is, but they should help us at least kind of get an idea of where these angles should be. And so theta 1, link 1 is going to be represented by the gray piece, and link 2 is going to be represented by the blue piece, which is shorter. Although again, I don't have an 11 to 7 ratio. I have closer to like a 5 to 3 ratio. But we'll put that one there. And it says the first linked one is at 0 degrees, so it's going to go straight along the axis, so it stops there. And then theta 2, remember, is the angle it makes with that point of action. So if it's 90 degrees, then that means I need to take this one and turn it 90 degrees. So again, while these are not proportional, I know basically what's going to happen is I'm going to have L1 is going to come out in this direction, and that L2 is going to go straight up in that direction. And it wants me to get what XY is. And so I could use our equation there, but really, since these are at right angles to each other, it's really pretty simple. I know that X is going to equal L1, which is 11 centimeters, and Y is going to equal L2, which is 7 centimeters. So that one I don't really have to get into the lengthy equation. So that one was easy enough. Question 2, theta 1 is 180 degrees. And theta 2 is 0 degrees. Alright, so again, let's draw an axis. This is the positive x direction, that's the positive y direction. So start with the gray one. The gray one is at 180 degrees, so that means it's going to be pointing directly that way. Theta 2 is the blue one. It's at 0 degrees, so it's going to stay along that same line of action. So what I have here is a situation where this is L1. Find my blue pen real quick. L2 keeps going in that direction. So X is going to be minus L1 and minus L2. So that's negative 11 minus 7, negative 18. And Y is going to be 0. So again, because they gave us easy angles to work with, we don't have to dig deep into trying to calculate something. The third one it asks for is theta 1 is negative 90, and theta 2 is negative 90. Alright, so let's draw it out again. Hopefully it doesn't end up over there where I put the coordinates, since where I put the coordinates, since it's pretty tight. Alright, so again, we start this one at the axis. It's going to go negative 90, which means it rotates that direction. The blue one's going to take that line of action and rotate negative 90, which means it's going to go that direction. Another way we might think about that is, before turning this, realign our paper. So we've done theta 1. Now from this one we know theta 2 must rotate that way. And then I'll rotate it back to where everything's square. So what this one's going to look like is I'm going to have L1 going that way, L2 takes off to the left, and again it's easy to get, this is the x part, that's the y part, so x is just going to be negative L2, which is negative 7 centimeters, and y is going to be negative L1, which is negative 11 centimeters. So if we only ever had to worry about right angles, we wouldn't have to worry about this equation. We can pretty much just add them. We can pretty much just figure out which one's going in which direction and put them in there. Alright. Which brings us to part 4, where of course they're going to start getting tricky with this. 45 degrees and 30 degrees. So theta 1 is 45 degrees, and theta 2 is 30 degrees. Alright, so let's draw an axis real quick again. I'm not going to get another problem on here anyway, so let's go ahead and extend it out. I've got to get 2 more done, so we'll move on to, we'll end up using another sheet anyway for this. Okay, so here's where we said it starts to get tricky. And I might not get these exact, but I can get them sort of looking right. So theta 1 is 45 degrees, so right out that way somewhere. And then from that, level it off. Theta 2 is going to change 30 degrees. So something like that maybe. That might be a bit far. If I keep it rotated straight the way I want it. So just to kind of redraw that. This one is going to be L1. That's a 45 degrees. We continue along that line of action. And I guess I should have kept making these blue. The L2s are blue. L2, and this part is theta 2, which is 30 degrees. So we remember from our equation above that x is going to equal L1 times cosine of theta, so it's going to be, well, let's just go ahead and write out the formula again, and then plug in the values. L1 we know is 11. Cosine theta 1 is 45 degrees. L2 is 7. Cosine of 45 plus 30. So that's going to end up being 75 degrees. So this is where a calculator is going to be really handy, because that's getting tough to do in our heads. So x is going to be 11 times the cosine of 45 plus 7 times the cosine of 75. And so I get that x is 9.59 centimeters. And for y, we'll use the similar equation, that it's L2 sine theta 2 plus L2 sine theta 1 plus theta 2. So y is equal to 11 sine of 45 degrees plus 7 sine of 75 degrees. Again, that comes from the 45 plus the 30. And so y is equal to 11 sine of 45 plus 7 sine of 75. And so that is 14.54 centimeters. Does that make sense? Well, they're both positive, and it looked to us that we were still in the first quadrant, so that makes sense. We're not completely proportioned here, but it does look like we're higher vertically than we are horizontally. So those at least make sense. Whether they're exactly right or not, we would have to check against things, but it seems like that worked out well. Okay, so the next example, again, this is still two-link planar robot, part B. This is question 5. Theta 1 equals 120 degrees. Theta 2 equals negative 45 degrees. And obviously I have a protractor in my hand, so if I wanted to, I could draw all of these perfectly to proportion by measuring and using a protractor. But that's really, and then really if I did it exactly, I could even measure my answers and see if they're right. But that's not what we're trying to do. We're trying to learn the math behind it and see how things go. All right. So again, length 1 is 120 degrees, so it's somewhere over here, up in that quadrant. So somewhere at 120 degrees. And then our second one is negative 45 degrees. So we take from this one, we go negative 45. So something like that. The question we would have to ask when drawing is it going to cross the axis? I don't know. It looks like for my pieces that they don't. But then again, my pieces are not the right proportions. So I'm going to draw it as if L1 is there. And then L2 takes off from that at kind of this angle. And I'm going to say it doesn't make it back across. The math is going to let me know. Alright, so the x component, again, I'm going to rewrite the equation on this sheet, especially since we just lost it over there. Remember, x is L1 cosine theta 1 plus L2 cosine of theta 1 plus theta 2. So it's 11 times the cosine of 120 plus 7 times the cosine of 120 minus 45 degrees. So let's put that in the calculator and see where our x ended up. 11 times the cosine of 45 plus 7 times the cosine of 120 minus 45. I put in the wrong numbers. The first one is cosine of 120. Alright, so it says that we get a number of negative 3.69 centimeters for our x value. And for our y value, again, I'm going to write the equation. L1 sine theta 1 plus L2 sine theta 1 plus theta 2. Y is 11 sine of 120 plus 7 sine of 120 minus 45. So what did we get for y? We are pretty sure y should be positive. Both parts of y are positive, so if we don't get a positive number for y, then we've really messed something up. And so we get that y is 16.29 centimeters. Okay, so there's our first really difficult one where we had to go off into a different spot. And then there's one left, number 6, within part B, is theta 1 equals negative 30 degrees, and theta 2 is equal to 90 degrees. Okay? So let's draw a coordinate system again. Let's take out our magic piece. And of course you don't have to do this every time to figure out the numbers. It just kind of helps me visualize. So negative 30 degrees is going to be somewhere down there. If we take it from there, we're going to go positive 90 degrees. So that means it should be perpendicular that way, because this angle is 90. So we should have something that looks like we're going to come out this way. For L1. And then I'm going to say, simply because the other one didn't, that this one probably does cross the axis for L2. So remember, this is our 30 degrees. This is our 90 degrees. But the math still works. Alright, so x. So let's skip writing the base equation. We've seen it enough times. Is going to be 11 times the cosine of negative 30 degrees plus 7 times the cosine of negative 30 plus 90 degrees. So it's going to be a positive 60 degrees in there if we want to work that out. But 11 cosine negative 30 plus 7 cosine negative 30 plus 90. And again, I didn't mention it earlier, but hopefully if you've gotten this far into the problem, you are in degrees as you're putting these into your calculator. If not, you've probably gotten much different answers than what I've come up with, and are very confused at this point. But I get 1303 centimeters for that. 13.03 for the x. For the y, it's 11 times the sine of negative 30 degrees plus 7 times the sine of negative 30 plus 90 degrees put it in the calculator, negative 30 and so cross, but not by much. So 0.56 centimeters. So I was right that it was positive, but it wasn't nearly as positive as I drew it. And so if I were doing this on a final answer, what would be a good idea would be to work this out by scratch and then come back and make sure that my graphs match what my answers say they're going to be. But that's how we would work questions with the planar robot if we're given the lengths and the two angles, how we can find the x and y components.